Our theory question 8b, which came in June, it is saying that when a fraction is reduced to its lowest term, it is equal to 3 over 4. The numerator of the fraction, when doubled, will be 34 greater than the denominator. Find the fraction. We are to find the fraction. Let us do this. When we have a fraction 5 over 10, and we want to reduce this fraction to its lowest term, what we do is that we find a common factor between 5 and 10. And the common factor between 5 and 10 is 5. The least common factor, just any common factor that can divide both 5 and 10 is 5. And when we do the division, we are going to get 1 over 2. If we want to get back our fraction, what we do is that we multiply the simplest form by the common factors, so that when 1 multiply 5, we get our 5 back, and 2 multiply by 5, we are going to get our 10. So our simplest form of the fraction is this one, and this is our common factor. So in our question that we have been given to dealt with, we have been given our simplest form, which is 3 over 4 of a fraction that we don't know, and we have to find the fraction, which means that before we had this simplest form, there exists a certain common factor. So we can say that let the common factor be x. So if our common factor is x, therefore our fraction will be 3 over 4 times x, this one times x, which is 3x over 4x. Now this is the representation of our fraction. The next part of the question says that the numerator of the fraction, when doubled, would be 34 greater than the denominator. Our numerator is 34. So when we double our numerator, it will be like this. It would be 34 greater than the denominator. So 34 greater than the denominator is written as 34 plus 4x. Now we have a simple mathematical equation to solve. So 2 times 3x, we are going to get 6x, which is equal to 34 plus 4x. We want to make x the surface, so we add the inverse of 4x to both sides, which will finally give us 6x minus 4x equals 34. When you add negative 4x here, it will cancel the positive 4x. So 6x minus 4x, we are going to get 2x, which is equal to 34. Our x equals, then we divide both sides by 2. So the 2 will take away this 2, so we will get 34 over 2. And when we divide 34 by 2, we are going to get 17. So the 17 is the value for the x. But the question is saying that we should find the fraction, and our fraction is this. So when we want to do substitution into 4x, 3x over 4x, we will get 3 into bracket 17 divided by 4 into bracket 17. And 17 times 3, we are going to get 51. 17 times 4, we are going to get 68. So the fraction that we are finding is 51 over 68. Our solution for theory question 13b, which also came in June. The question states that the operation star is defined on the set R of real numbers by m star n equals negative n over m squared plus 1. Where the elements m and n are elements of real number system. So if negative 3 and negative 10 are elements of R, show whether or not the operation star is commutative. So the question is saying that negative 3 and negative 10 are elements of R, which show that the operation star is commutative. So for the first thing we will do, our m will represent negative 3 and our n will represent negative 10. So rewriting negative 3 and negative 10 in the form of this will be negative 3 star negative 10, which is equal to the n represents negative 10. So negative 10 divided by our m, which is negative 3. Negative 3 squared plus 1. And we are going to get 10 over 9 plus 1, which is going to give you 10 over 10. So at the end, 10 over 10 is going to give us 1. Now for commutativity, negative 3 star negative 10 should also be equal to negative 10 star negative 3. So in case we do this and we are not getting 1, it means the operation is not commutative. That's what it means. So rewriting this, our n is negative, the value of n is 3 over negative 10 squared plus 1. So at the numerator side, we are going to get 3 divided by negative 10 squared is 100. 100 plus 1. And at the end, we are going to get 3 over 101. 3 over 101. So we can see that negative 3 star negative 10 is not equal to negative 10 star negative 3. So negative 3 star negative 10 is not equal to negative 10 star negative 3. Hence, we say that the operation star is not commutative. So in case when we operated this one, we also have one, then it's going to be commutative. But since the results are different, the operation star is not commutative.